pattern. I'm going to show you the pattern. So we're going to use this because if I go through the whole back, you may end up. So I will show you the pattern I just explained. So I'm going to we were running our tapes. We are still on our tapes. So we had fed in the notches. Now we are in the force, the beam end reactions. Now the beam end reaction, if you have your Tekla, the designer, yeah, you open that. The first corner, which so we see from your designer, there must be immediately that there and give the numbers for that day. Because if you look at your project, when we are designing, there is the beam end reaction. So when you click on beam end reaction, it's going to show you the supported beam end reaction. So it wants you to specify the what? The load, the force at that point. So if you have to describe this, sorry? 0.904 in kilo. No. I said you have to know the principle of loading. How to be this thing is supported at this point and this point. Now meaning the moment the load slowly we take that load on a beam, take off from the slab that put at the center. So what happens with this body, half of it goes to one side, half from this side. But remember, maybe when you are getting your loading from that, you need to know that whatever load that you have, the G wave, and quickly, you must remove away the one on the roof, on the G wave, deduct it away. Then for the roof, you remove away the one from the roof, because on a slab, this will take, when you look at this beam, this is the beam. Because I'm going to design all of these things, the specimen the same, and the same design for all of them. So I'll say this one is taken, it will take a half of the slope. So if it is 0.9, so you get 0.92, and half this, it will still give you 0.94. Some people like following like more of the last detail, when you check whether the slab is two-way or one-way slab, then after that the load is distributed in this format. But if you be safe, and I know that to go through, if you have to go through all this, time may not. So what you do is just take it will take a half. Then it will take a half like that. So then you have half of this, and the half of this only which that is carrying part of the slab that this is carrying was what? 0.92. But then, the overall is only in the loading area to repeat shaded one. This is what beam is carrying. So my question is, from the load that we have got, you get the load for the roof removed, so what the left is the dead load, and the last load we have to kill it on back. new model. Depending on the purpose of the unit. Then the given the load generated from loading. So I'm just going to imagine. I'm going to imagine that okay, from the model we have, was it 5.717 kilonewton per millimeter square? The average weight. And this was including load now of the roof. So if the load, only if you can check it in Tesla, you can just keep it there. So this is what I'm going to do. My isection. So meaning the load is here. The load of the slab plus the load of the isection. And then you have to display it in higher dimension. So my isection that I'm using for the intermediate was a 203. 203 here. Yes, it was this. And it weight is kilogram. So meaning extract that kilogram. Per meter. So meaning per meter. But how long is that isection? Meaning my load is for I section is 25 kg, but I don't say 1. Are you getting? So meaning I'll start by my I section, yeah? So meaning loading due to I section. P equals to I have my 25 times the meter that I have. Yeah? 3. So we had it to be 3.12. But this is in kilogram. So I want to convert it to kilonewton. I multiply by gravity times 9.81. So it is already in Newton. Now I want to convert it from Newton to kilo Newton. So I divide it by what do you get? Two point 37. This is kilonewton. Now that's due to I section. Then due to slab. After removing the load of the roof, right? But for my case, I'll just take that point the way it is. It's 0.7. So meaning this was 0.765 kilonewton. Now that's weight due to the I section. Now weight due to the slab. I'm just going to take the 5.12 here times we multiply it by the slab area. So my slab area, meaning the section of that part that being slide is going to be 0.9 by 3.12. So we multiply is 0.904 by 3.1. I mean it is 3.12 here. What do you get? See, 5.12 times 0.904 times 3.12, 14.4 kilonewton. Now this is due to the slab. Maybe the finishes, all I've done them. Which one is? Yes, per meter. That's why you find the running always UB20313 5 kg per meter. So meaning per meter. So when you get it its weight, get the total length times that meter. Get it? So this is for weight. So meaning the 25 times the 3. That's why we have a 25 times 3.12, which is the length. So what we are getting is kilograms times the gravity to convert it to kilonewton, to Newton. Then we divide it by 1000 to convert it to kilonewton. That's why we have this. Then the slab, that load that we have got from here, Tekla the structure, times you multiply by the slab area. Because this load was given in kilonewton per meter square. So you multiply by the area that thing is carrying. So meaning we have it to be 14. I sum out my GK. Total GK will be 14 plus this. What do you get? Sorry? Okay. This on the I section we have at 203 by 133 by 25 kg per meter. But this length, the length was 3.12. So meaning when I get 125 per meter, which is 3.12, I'll get a kilogram. See it? So now, this is what we have. From multiplied by 190. So I'm putting it is in kilogram. Multiplied by gravity. Because weight is the same as mass times. So I'll convert it into newtons. Divided by 1000, I'll convert it to kilo. So it's already kilonewton. So now meaning I have these two. 0.75 plus 14.4, what do you get? 50 to 1 kilonewton. This is the GK. Then you have to get the QK. QK is given, since it's a geometry, we know how to get it. So maybe QK is 2 kilonewton per meter square. You multiply by that area. So maybe QK equals 2 times, you have to make 2 times 9.81. What do you get? 5.6. Yes, this is kilonewton. Now, when you see what is giving you the end reaction, it wants just a load. So you have to factor. So maybe I'm going to take a load case of our design load. You could say 1.35 GK plus 1.5 QK. Maybe your design load then equals to 1.35 times the GK that we have. 15.1. 15.21 plus 1.5 times the QK, which is 5.6. Your design load will be 28.9 kilonewton. That's what you feel. That will be the end reaction. Now, but this that you have calculated, if you look at what we have, you have taken the total length. But the other loads, how the load moves, we say when it is loaded on this beam, I have a big force here, I have a big counter. Then the end reaction at this point will be a half. So when you are ready to divide this to get the end reaction. Reaction divided by 2. Here we have 14.5 kilonewton and you press OK. Now it's telling you here to specify the end plate well length, leg length. So you can specify there 6, 4, the thickness. So mine I'm leaving it at 6. Then you see here it's talking about the weld design strength. Weld design strength is so much dependent on the thickness of weld that you put. If you guys know when you are signing, it's full welding, the spotting, you get it? But here you have to calculate its strength. Now Eurocode gives us that. Yes, you open the Eurocode 3. Go to Eurocode 3. Okay, we use this to move faster. Now, you check in Eurocode 3, page 29, yeah? 39, sorry.
This is 23. Let's check in 20, 39. Check 33, 35. This is 38. Yes, 39. It's here. Now you see here, it's talking about the design shear strength of a weld. A formula is given. It's root of 3 divided by. So it's the same as FU divided by root of 3 divided by BW divided by B divided by BW. Our design strength of that weld, which is given by formula of FW, make FU divided by a root of 3 BW times M2 under root. That will give you the shear strength of the weld that we are designing for. So, after filling that formula, let's see how do you get your FU. Now, for FU, you could give us the value direct that if you have used a steel plate of 275, take FU to be 470 Newton per millimeter square. So for that, we're getting 275. So we have FU be equal to 470 Newton per millimeter square. Then let's check out the BW. So to get the BW, you could specify, it is a national annex, yeah? It specifies the value. It gives you that, take it to be 1.25. So meaning your BW is 1.5. Then, let's check on the one for the, or else you can still check on the same page but 32, yeah? Let's see how that value comes about. When I come back here, so what grade are we using to, or are using this? So meaning, in national goes down again grade. Tell us we use it to be 7.25. Meaning instead of using this, our national and extract that BW to be 0.35. So I want to take this, we go to national and we take that. Say you will not be wrong side. So, really we have this, we have this, we are left with this. So let's see what tells us. Now, for the gamma, sorry, gamma also, you have to take 1.25. So you can just feed in that figure. Then, after feeding, you come up with your design. So you have 470 divided by you have 2 plus 3 times BW is 0.85 times 1.25. You get 100. Has a root. Yes, sorry. So the shear strength is 255.4. So then you back to my euro code and feed it in. So you can go down there where they have said 220, 20. You adjust yours. So really 200 55 on your Z. 255. Then go ahead and press finish. So ensure that you have adjusted, you have your notch, the top notch, 73.75. Then ensure that the depth of the notch is 55. Then you have 73.75 down. Then just cross check. Then you go to OK. The force, we have loaded our force, yeah? You press OK. The shear strength of our weld, the welding we are doing, we have loaded it, that value we have got. So you press finish. And you allow it to design for you. So that's what are we going there? Sorry? Let me take it back. So this is where are we going here? I say go ahead and press finish to run the analysis and design. Are we there? Sorry? To specify for you the big thing. So here, after you're fed in, you run the analysis. Then you cross-check through. You see here what is telling you the ball gauge is out of range. Then you see here the shear capacity of the ball group is supported. So here it has passed. Now the shear capacity here also has passed. I see. Then when you look at this, the check shear capacity of this beam also has passed. Then when you check here, shear also passed. Here shear has passed. You see? So you go through your report and check. You get it? It shows you it has passed. The date of notching has for notching. Yes. So, meaning, that's why for us when you are doing our design, we figure it out. Because I didn't want us to grab. Figure it out and just somewhere. Meaning, if we want to deep pass, we go through the procedures, calculate. So you try feed it, calculate, then run it will pass. So what I'm interested here is when you look at what is failing is that depth of the notch, of which I will leave it for you guys to handle that. But when you look at the shear strength and everything of the waves, the word they have all passed. Meaning I can go ahead and say print, Control P. Then I stick it somewhere because I'm going to use it. Then I press, print it. You make sure this is in PDF. Then you say OK. Then you go and save it on the desktop. And you can say beam connection. I save it. Have we all saved it? We're all there. Are we there? Are we all there? Yeah. So the moment I finish this, let me try to summarize it. Let's say I have my report, the connection report, the column detail, the base plate, the footing. So I want to detail it in Tekla structure. Now instead of detailing
Firstly, I try to extract this section. It's what I'm going to detail. So, this is what I'm going. This is the section I have, the I have so if I have this, one, open your Tekla structure. Just go and double click. However, what I can tell you with Tekla structure, it needs you to have a laptop that is on. So if you want to, like if you're doing complex structure that are 2 units, at least minimum you have 4 GB or 16 inside. Then you can easily run it smoothly. Now, once I've opened, it tells me the environment. So you have to ensure, for your case, we have installed on a Europol. But you may find American standard, all of them are there. So you ensure that environment is in UK. So you go and select UK. The roles, what are you going to use this for? You can choose any of these. Bridge, you want to use it for contract, modeling, concrete, structure. I'm leaving mine in steel detailing. Then now this configuration, the way you will select this will so much depend on the purpose of what you want to use it for. So if we just say this is steel detailing, developer, diamond, drafter. So if you select it and you select the drafter, it will limit some feature of Tekla that you're using. You get it? So ensure that you have it in steel detailing. Are we there? So that you are not limited from any other feature, then press OK. Then it will open. Are we all there? On configuration, you select steel detailing. Because if you select any other type, it will limit other function. Yes. We're there. Now, once you have opened steel detailing, it's not a crime to double check. Go on this other side. Ensure that you are having UK. I see. If you have something different from UK, the role is still detailer, so meaning your setting was not set. If you go detailing, the other side is something else. So what you do is you just check through this, then go here and click on new. Then you type the name of the model you want to use. Are we there? We're all there? So I can just say maybe I'm just making the short form, DO, so you can write geometry, you can write anything, what you're designing, then you press create and wait for it to load. If you're not having a higher amount, your computer one freezes. So this is what is open. Is it open? You have got open. So we can proceed. After that, I just cancel out this. So this is the environment I'm having. So I'm only going to pick out the ways. So you go here and first start with your grid line, double click on this grid. When you double click, it will open this. You want to wrong. Complete now in dimension. So now we are going to model because we have time is against us. How we are going to model maybe something like 7 things. So I need to be a bit fast. When I say click this, click it, then we move. Now, so checking here, we have the coordinates. When you look at this, it's giving you in terms of your. You double click, go to your grid line. Double click on grid line. So you see here it specifies for you. There is X, it is numbering them. Then there is X distance here, we have 0, 0. So all of them are static at 0, 0, 0, 0, 0, 0, even the Z. Now this will define your grid line. So meaning I have 0, I'll press space, but when I do this, it will try to make the next grid line. On the Y, what I will do is, this is 1, I'll press the 0 point. Then I press space like this. So it gives you the distance here, it is in millimeter, yeah? So meaning what I will do is I'll start with the 0, say space, on the x-axis, 3610. So that's what we're having, eh? Now on the Y, so meaning that's the next grid. Now if I had another grid, I would press space and then I hide. So on the X, on the Y, the same thing. 0, space, then I write 312. 3120. We are there? Then the naming, meaning the first grid on 00 is A. The next one, space, it's B. You type in B. Are we all there? Then in the Y, it's 1. In the next one, space, type 2. Then on the Z, it's talking about levels. The first, for our part, let's say the column was going to 105, the way we designed yesterday. The part is taking around, let's say 300. So meaning I'll add 105 plus what? 300. What do we get? You get 135. Eh? So meaning I'll set space, you say 1350. Then space again. Then you press, now this has to be in meter. So it is 1.350 is my first. But since it's going to be in the foundation, you put a negative. Just say negative 1.35. Eh? Then in the next one, space. You press space, then you type in. You reduce on the height. So meaning we are going to do 1. The next one, space. It is 3 meters. The height.
3, it adds up to 6. Meaning, before reaching 1, if you come from negative, because this was negative 1, then we go to 0 at the ground level. Space 0, space 3, space 6. Are we all there? Are we there? Now, once you're done, you come here and press modify. You see what it has done here? It has placed for you the grid. That is basically what this is. Now, if I'm done with that, I go, you see, it is out of this box. My click is part out of the box. So you go and click on that box, right click, and say fit area entire model. When you click it, you will take it. Go in this box, right click, then click on fit the entire model. Are we there? So, once I've done that, go and click on double click on this column. Then once you have double click on it, come and place it. It tells you whether you want to expand it or do not expand. Expanding it wants you to fit it in that box. So I will say expand it because I haven't specified the height. We are there? Just click on it, go and click on and say expand. Click on the grid line and say expand. It's there. After I've done that, I can right click and say interrupt because I want it to release that command of column. So I say interrupt, so it will release it. Are we there? Then double click on that column. Now this is the feature of that column. When you come here, you see it talks about the name, it's column. It talks about the profile, then talks about the strength of the material. Now the profile is 254 by 254 by 73. So meaning what I will have to do is I have to change it. I go and click on that icon and wait for it to load. Are you there? Now the column we were using was a 155, 152. So meaning I go and look for where there is a universal column UC, which is this. Once you click on it, it will open this. But there is an option of a 152 down. I see. Click on that plus sign. Once you click, you see you have your grade of the one of 152 by 152. You click on it, then you say apply and press OK. So it will change it from the model, this side. Then the strength, we have it. The color, this is for the color, this is numbering. Because when you're going to generate your drawing, it will have the numbering. Go to where there is profile. When you're on profile, click on this and wait for it to load. Okay, for the purpose, for the interest of time, I'll just pick that column, only one column, put the best. Then I'll go for your beam, connect the beam to a column and do the best, then run the drawing. Then for you, you will do the same thing. So get this concept and it's what you follow for all of them. So you choose this. We have a 152 by 152 by 23. Are we there? Click on it, press apply, press OK. Once you're pressed on OK, go down here and see here, you have the level. positioning. So in positioning, you have here there is middle. Now this is when you want to turn the column in any direction. So if I click on, I want it to be in the middle. Then rotation. You want to rotate it in this, when you open my column, so you can say, maybe instead of top, I can say front. After that, specify the height down. Where it talks of the top, it gives you the top level. What top level do you need? So I can find from 0 level. From 0 level, I will be 6 meters. So I put in 6,000, yeah? Are you there? Then the starting level, the bottom, it had already put for me 450. Then what I do is I put 0. Because I want it to start from after putting it at 0, you go and say modify. You see it has adjusted it up to 0. When you go and just put the cursor, it will show you the dimension of that. You can check in case you are designing and you have forgotten or you have closed your laptop. When you click on it and right click, you can go here and say inquire. You see, when you press on inquire, it will show you everything about that column. The height, the kilogram, everything. So you can inquire the feature of that column. So meaning you want to place the concrete base. I go and click on where there is concrete. Have you clicked? Where there is concrete? Click on concrete. Then go to where there is footing. Click on that footing. Are you there? Then click on the pad footing. Once you click on the pad footing, it will give you the feature here. Down. What is the size? I see. Now for us, we have designed for a size of 1. So I just changed it. Instead of 1.5 by 1.5, I'll say 1100. I change this also to 1100. Are you there? Then the class of concrete you have used. This is starter, yeah? So when you click here, you see it has various options. 20 stroke data, so we have used 20 stock data in our design. You press OK. Now you're getting this from your report that you had. After that, you go here. What is your top level of that footing? If you're going to do, remember what we said, the footing starts from some level of 300 now. So you realize the start point is 1 meter, the footing is 300, so in total is 1.4. But down in foundation, so meaning we shall use negative 1,300 to be our top of that footing. Then the bottom, meaning the top of the footing is exactly flashing the column. So meaning where the level of the column 1 meter is the start column, it will be like our top of the 1,000, yeah? So you change that to 1,000. Then the bottom, that's negative 1,000. Then on the bottom part of the footing. Now from the negative 1,000 that you add about 300. So be negative 1,300. After that, you can go ahead and say, you go here where that grid is and click and say expand. It will place that footing. See where it has placed it? Down. So to do your column, the same thing. You have your column, you click on the column. After you clicked on the column, you come and specify what is the height, because that was a concrete column. Yeah? So we had a size. What is the size of that column? It's 300 by 300. So you go here and change this to 3. Then here also you change it to 3. Then you change the class. Are we there? When you click on this, it will give you an option of C25 turtle. You click on C25 turtle, then you say apply, okay. Then after that you specify the height. Now our height now is 6, which is at 0. So meaning I have it at 0. Then the bottom part of it, it has to start from where the top part is. So you put negative 1000 at the bottom. Then you come to where this is. You click, it will place it there. You there? So the same thing, the way I've done this column, after you've done one, if you want to draw those other one, you will just go and highlight and say, I'm going to draw for the next one, using the same thing I have. Then I connect the beam and take it for detailing, then we summarize. So once I have this, I go to where there is a grid line, double click on your grid line, then right click on it. I see the grid line, double click on it, right click on it, then say create view. Now the best thing with Tekla structure, once you say create view, it will look at all the grid line, looks at all the levels, and then bring all the views at different levels and open it up. So when you are working on one side of that, the rest, if you create it at this stage, the rest will be changing what? Automatically. So meaning I can say create view the moment I've done one. Then I go to along the grid lines. Then you click on it. Then you just go and click on create. You see what it's giving me here? The plan at 0. So it's giving me the plan level at 0. So this shows me that when you look at what we're having, we have the plan, elevation, you click on it, press next, then you click on along grid line A, next, along B, next, grid 2, next, grid 1, next. All those drawings are created, then you press OK, press OK. So if you are working on one, all those ones will be changing automatically. So if I have this, and then maybe, let's say, we look at the plan view, we are going to work on these two, and see what effect will be happening on this other one. Are we there? Yes, how we got there? We are all there. So we have designed one column, so we are going to put the next one and then detail and generate the drawing. So the same principle you will do for all of them. But I will give you an option of how do you copy what you have designed to ensure all of them are moving there. Now meaning instead of me going through all that, let me put the base plate for this, and I know that even when I do the next one, it will have the base plate. So I can go here to where there is component, application and component. Go to this icon, application and component, click on it. Now when you click on application and component, you see down here there is connection. Just click on this drop down menu. It has all the types of connections that you've been using, designing it. Are we there? Just get the thing that you're going to have this. Well, then what? Or else, let's say you don't know, but you want that specific thing. There is always a search key. You can just go there, type anything like base. It will bring for you base things. If you don't know, maybe knowing even the code number, you can type 104 something. You will see the kind of connection it's bringing you. I see that. So if time and time and again you repeat it, maybe you have no spot, just type, it brings you instead of scrolling, just pick it. So mine, I want base plate. So there are various base plate here. There are some with, you see this, with stiffeners for rigidity. So meaning me, I'll choose this 1042. Now in the next time when you remember this number, instead of searching, you just say 1042. And you see what it does? You just pick what you want exactly. So what you do is you click on it. After clicking on it, come here and click this column. Then click on the endpoint here. Then wait for it. It will put the base plate. I see that. Are we there? Now, when you look at what you have, this is what we are having. So you click on right click and say, you right click and you go up here and say, interrupt. So this is what you're having. Are we together? Now when you look at what you're having, size is way beyond. From the data that we're designing, you have to do these things. So meaning you come here, you edit this base plate, you double click on it. When you double click, it opens the filter for the base plate. Then you start feeding in your dimension that you're picking from the report that you have got. Now meaning, I'll have this is giving me from this to the edge here, what distance is it supposed to be? So meaning I'll get my I section, if it was a 2 from our report, the I section was 15052. But the best plate we had was 300, is it 300? Yeah, so if it's 300, you will deduct that I section length. If you remove 152, 300 minus 152, what do you get? 148. So 148 divided by 2 because it has to be on either side. How did you get it? Okay, have you double click on the base plate? So, from your detailing report, go and extract the base plate. So we are designing. This was 112, maybe it was 300. Maybe 300 by, let's say 300. Then I say from the design, something like that. Now, when you look at this dimension, it's very clear how far is the column away from the edge of the best plate. It's what you need to feel. Even here, the best thing is it shows you the drawing. So what we do is, to get this distance and this one here, you go ahead and get the length of the best plate minus the length of the column divided by 2. It's what you see on either side.
So meaning you have a so when you get 300 minus 1.5 74. So you feed in side 74, then you feed in this other side also 74. Then you go here. Now, this other one, I have shown you how this plate was on this side. Now, you want to give also the width of the plate. So you have to identify. You see here, this is the thickness of the plate you're using, which you pick from your design. That's our thickness. What about the width of the plate? So you pick from your design report. So from the design report we had, what was the width? Just open your report. So you feed in here because you see it gives you plate and it says TBH. So meaning T is the thickness. You're going to use the 12. The B is the width of that plate. It was 15, eh? Yes, so I'm putting 15. The width, we are checking the report. We had the report. Let me open mine. Huh? Okay. Let me open the report. The length was 300, eh? Sorry, I'm not seeing my report. Eh? So we feed it. If it's 300, you can say 300. The depth also was 300. Then you can go ahead. The material you have used. What kind of material are you using for that plate? So you can select on steel and say apply. Then you press OK. Go and select on steel, apply, OK. Steel, apply, OK. Then once you place on steel, apply, OK, and then you say show alliance. So under this, it will give you the kind of plate. Is it not under what we're using? You can go here and select. There is American standard, there is Eurocode, there is. So you choose the one you have gone for. Then when you press apply, you cancel. Then you go to this other side. This shows you the ball details. You click on this. What was the size of the ball? Okay. 12. You click on that. Of course, you do all those modifications. Then the ball type, you see here, we had selected and our design was 8.8. So I'm going to use 8.8 XOX here. Commonly, you can find in Uganda. So after that, I press modify, apply, OK. See now my base plate just fits exactly. After you've done that, as you're working here, this is changing. So meaning all those other parts will be changing. Now if it was for doing a beam, I would click on a beam, steel beam, click on that beam. After clicking on the beam, you can double click on it, specify the height. If I say I want to put it at a height about the ground, yeah, that's the Y distance. When you look at it here, it will show you. So you have Z up, you have Y here, X here. So you can say I want to place it on the what? The Z, but what is the distance? You specify in millimeters, so 3000.
Then you come back here on your ground floor plan. You click on this. Then up to where you want to draw it to. You click on here. Then you say expand. It will place the beam. So when you're looking at, you see here, the first end part of the beam at say 300. So, meaning when you change also on this other, this is on the Z, change it to 3,000. Press on this, escape, interact. Then you click on this beam future. Then you say, I want this end part because this is starting part. If you are saying it, this is the ending part. So the ending part also, this is for you to, whether you want to model the staircase. That's how you can tilt the beam. At what height you tilt it the way you want. Then you model your staircase. But if you want to do the same level, so the starting part was at 3 meters. The ending part, what do I want? At 3 meters. Then you say modify. See what happens? Now, if you have done all this, the only thing is, if you are drawing another one, you will just click on this, right click, then you just go and you see here, there is a copy, special copy. Then you click on linear copy. If you want to specify in terms of a distance, either copy it up, copy it down, move it along the side. So what I will do, if I want to place it in specific point, I come and pick this point. I pick up this point. Yes, I pick up this point. I move it to the point that I want to place it at. I click. Then I come and click on copy. It will place that beam in that position. You see that? Now let's say you're done with this. You have modeled your structure. The same procedure as putting column beam, the way you are putting. Specify the height. Then come here and right click. But before you right click, go to view. Drawings and reports. You see that? Meaning the same way you have placed the base plate and you edit, the same way you will place the connection of this and you edit, depending on what you had in your report. Then after that, you go here to where drawings. Let's say we want to come out with assembling drawings for this. You go to where there is drawing, then you say drawing property, set out the drawing property. Drawing property, then you go to where there is GA drawing. You click on GA drawing. It has the properties here. Now, I'm only going to talk about few properties. See this part mark? Because you don't want to keep detailing the part that is already there. You've already put it. So, I will make sure this is thick. Part mark is thick. You take out all these features, depending on what you want. If you want, when you're doing your drawing, the part mark should not be automatical. You want to detail it yourself. You will not tick this. So me, I will leave part mark. I say get, then I say apply, and I press on OK. Then after pressing OK, I go to create. So which drawing do I want to create? I click on all what I want to create. You click on this, press Ctrl, click, select all what you want to create. Then say create. But I'll press on, you select all of them, then you say create and open. Then you wait for it to create and open. So you see, this is what Tekla does. Now once you clicked on that, meaning when you have modeled the whole of your entire structure, your task is just go and create the drawing the way it is. It will, all the drawings, the part that you have selected is created. Now if you want it to name anything in this, I'll click on that. You see I've clicked on base plate, right click on the base plate, then you see you move here to add mark. That's how you will be detailing, meaning you do all the detailing, but once you bring it to you don't need to add mark, will be putting the details. So you just go here and click on use applied mark property that you had already applied what you're using. So you click on that. See what it has done here. You click on this. Now recently up or down that. What do I want to put? Because I have not specified it. So I double click on that. So in the path map, what do I want? You have to select what you need from here. Choose I need a profile, say add. So you specify the profile. Now you choose what you know. You as someone at site will need when he's doing the work. So I'll tell him, tell that guy the profile. What is the plate size and what have you. Tell him also the material you have used. So you keep selecting what you want. Tell him maybe the length, tell him the size. Then apply. Modify. Okay. See what has happened here? It is giving me everything about that display. The same principle apply. If I want to specify this, just where the ball is, I'll go and click on it. When I click, you see it select. I right click on it. I say add path mark. I slide it this side. I say use applied mark property. You see this time now it's automatically telling me that that is 18 for the hole that is there. So the same principle. Let's say now you wanted to get a section of just specific part. The same thing you will do now for this column. I will click on it, right click on it, say go and add mark, go here, click on this. You see what it's telling me about the column? Specify the size of the column. So you see 1 this by 20 straight from just the column. So the same thing, even with the beam. So this is what you'll be doing. You can do it in anywhere, elevation, all what you have here. So meaning the same thing, I'll come to this. For the beam, click, right click, add path mark, same principle. Maybe with this, maybe I beg to stop here, but use the same principle as long as your code is, because time is again is hard. As long as your code is, you model your structure. Once you've modeled, make sure that you tell specify this. So the moment you have said it, then you generate the drawing. Once you have generated the drawing, it will bring for you the drawing without the part. So when you want any part to be detailed, you only right click on that part, then say add the part mark. It will bring what you want. So meaning if I want the size, everything that someone will use at site, I will do that. So once you've done that, is even having a template for you to print. You get it? You can even say Ctrl P. Then you print out your drawing. Or if it fails to give you an option of Ctrl P, you go up here. Just print. Press print. Then you can name the drawing any what you have been doing. Then you can say press print. Then you can save it either to a desktop. You click on desktop. The drawing name, you can say GY, maybe GR, say save. So, if I go to desktop, I'll find that drawing is there. See, this is the PDF of that. Just pick and you take then you run the design. Once you type in what you're going to your report, you can feed it. Then after that, you just create the drawing.
like to stop here. But feel free, in case you do not get anything. My exam, like contact our country. Then there are some videos I have. You can as well give you those videos. Then you follow them up.